In this example, we want to use the properties of logarithms and the logarithmic property of equality to solve the logarithmic equation. So in this example, we have the equation 2 log of x plus 4 equals log of 36 plus log of 4. If we want to use the property of equality, we need our equation to fit a certain format. And that format is to have log base b of some expression equals log base b of some expression. So the key part is having log with the same base on both sides of the equation. Now we do have log, and there's no base specified, so this is base 10, and that same log on the other side. But we need to have a single log on the left and a single log on the right. This 2 is preventing us from having a single log on the left, and the fact that we're adding 2 logs together is preventing us from having a single log on the right. That's where the properties of logarithms come in to help us with this. We have 2 properties that we're going to use, the product rule for logarithms and the power rule for logarithms. So the product rule for logarithms says this: if you have log base b of m times n, you can write that as log base b of m plus log base b of n. Now we're really using this in reverse because we want to get down to a single log. So if we have the sum of 2 logs with the same base, we can turn that into a single log with multiplication, and that's why this is called the product rule. The other rule that we're going to use is the power rule for logarithms, and the power rule for logarithms has log base b of m to a power, and it allows us to take that power and turn it into the coefficient on the log. So this, we're going in reverse. We have a coefficient and we're going to move that into a power so that we have the log isolated on one side. So let's use those 2 properties. Let me first rewrite our equation. That's 2 log of x plus 4 equals log of 36 plus log of 4. On the left-hand side, I'll use that power rule to move the coefficient of 2 into the exponent, and that gives log of x plus 4 squared. On the right-hand side, I'm going to use the product rule for logarithms. I have the sum of 2 logs with the same base, so I'm going to be able to multiply 36 times 4 into a single log. And 36 times 4 will be how much? I'm thinking 144, but let me double check. That is log of 144. So now we have this in the format where we can use the property of equality. The property of equality says when you have log base b on one side and the same log base b on the other side, that what's inside the log on the left must equal what's inside the log on the right. This stems from a property of logarithms called the one-to-one property. So we're going to be able to simplify this equation, eliminating those logs, and write this as x plus 4 squared equals 144. And now that the logs are gone, we'll solve this quadratic equation. I'm going to solve by square rooting both sides. The square root and the square cancel each other out, giving me x plus 4. The square root of 144 is 12, and we need plus or minus. And I'll subtract 4 on both sides. That gives x equals negative 4 plus or minus 12. Negative 4 plus 12 will be 8, and negative 4 minus 12 will be negative 16. Now this is a log equation, and log expressions have restricted domains. So every time we solve a log equation, we need to check to make sure that these values are in the domain. So let's check x equals 8. In the original equation, that's 2 log of 8 plus 4 equals log of 36 plus log of 4. Now the restriction on logs is that you must take the log of a positive. 8 plus 4 is a positive, and so we'll keep that solution of 8. Now let's check x equal negative 16. In the original, that's 2 log of negative 16 plus 4 equals log of 36 plus log of 4. Negative 16 plus 4 is negative, and log of a negative is undefined, so we have to throw that solution of negative 16 away. And the only solution to this log equation is x equals 8. Thank you for checking out my videos. Have a great day.